So the fault tree analysis, the data dependency diagrams, and the Markov analysis, you can really do both qualitatively, so without the numbers, without the info on the actual failure rates and probabilities, or you can do them quantitatively with, so that means with the information about the failure rates. If you do them qualitatively, this is typically part of the PSA, the Preliminary System Safety Assessment, and if you do it quantitatively, this is typically part of the System Safety Assessment. Well, slides 110 and 111 just gives you a little bit what a Preliminary System Safety Assessment document would look like, and I won't go into too much detail there. So what we're going to talk about next is a tool that is part of the System Safety Assessment. Remember, System Safety Assessment, we try to verify the safety requirements that we have established. Now, the failure modes and effects analysis is so late in the life cycle model that at that time we know what the design looks like. So we have all the information, all the detailed information regarding very low level design, regarding failure rates of components, etc., etc. So in the failure modes and effects analysis, we do kind of take a bottom-up approach to identifying the failure modes, and we check out what kind of effect this failure mode has on the next higher level. Now, two ways we can look at this: either functional, so we do it at a functional level. We'll say, for example, if we have a component and this component has a wrong output, what kind of effect does that wrong output have on the subsystem above it, and then again on the system above it. In the piece part, we look at individual components, like for example, if I have an electronic component like a capacitor and it would fail, what effect does it have on the system? So in preparation, of course, we want to have all the information, so all the specifications of the system, the drawings, the schematics, the list of parts, any functional block diagrams that indicate how particular functions or components are related, and any additional material that explains how it works, how it operates, and of course the list of failure rates of all these components. So what you will see is then, and of course also the design changes and revisions, if they exist. In other words, you want to have as much information as possible. Without all the information, it's really hard to make a good assessment, perform a good failure modes and effects analysis. Now, as I said, a functional FMEA, you perform it at the function, item, system, subsystem, component level. So you can think about it, okay, maybe a particular card that's in a computer box, or a line replacement unit, which is like just an avionics block in an aircraft, for example, or the system itself. And basically you can say, if you have, for example, one of the cards that has an electrical circuit, you can say, well, what happens when I lose all the digital outputs of this particular card, or when I have incorrect digital outputs, or I have noise on the outputs, etc., etc. So you're going to say, okay, if that happens, what effect does it have of the system that has the card embedded in it? I have a graphics card I'm working about, and I'm saying, okay, there is some kind of loss of digital outputs. You're going to check out, okay, what effect does the loss of the digital outputs of this graphic cards have on the computer system it's inside of. Piece FMEA, you're going to really look at the component level. So I'm going to say, if a capacitor shorts or opens, or it decreases in terms of value, if a bipolar transistor gets overstressed, or there's degraded leakage currents. So you're going to look at if these piece components are really failing, what's going on. Now, if you do this kind of analysis, you kind of want to be very structured about it, very well organized. So it's always good to use some kind of worksheet. And I gave an example here. So I identified a system, subsystem, or item. I identified a function name, code if you have it. What kind of failure mode you're talking about? Is this a short? Is this an open? Or do I a decrease in voltage or a specification number? Yeah, I also identified the failure rates at which you think that would happen, the phase of flight at which the phase of flight during which this happens, and I'm going to evaluate what the effects of the failure. Can I come up with any detections or any commentary if I have some? So this particular worksheet example shows this for a 5-volt system. So this is I'm providing 5 volts to my system, and 5 volts can be out of spec, they can be short to ground, there can be reduced filtering, can also be open. And again, I show what the failure rates are that I think this happens, and now I know these failure rates based on the fact that I'm really far along in my design. I've kind of specified exactly what my design is going to look like, so you should know these kind of numbers. Of course, what you have to realize is that this particular failure may have an effect, and that's one thing that's what you're really gonna evaluate here. You're going to check out, okay, I'm doing a bottom-up approach, and we're going to check out what kind of consequences this failure have for the system above it. And this could possibly mean that the power supply shuts down. Of course, in most cases, you can come up with a detection method, and if you can detect it, you can also pass a flag around, and then people at least know that the failure did occur. Now, typically, and as you can see, these tables can become quite extensive. So, a lot of cases people make what they call a failure modes and effects summary that only really identifies the failures that are really very critical. And then finally, you may have heard of, instead of an FMEA, an FMECA, which is a failure modes, effects, and criticality analysis. Really what this does, it adds the criticality analysis to the FMEA. Now, it charts the probability of failure modes against the severity of the consequences. There will be some failure rates, which is of course related to failure probability if you multiply it by the exposure time, and of course what the effect is. So if you're gonna evaluate this failure rate or failure probability in combined with the failure effect, you can also perform a criticality analysis. How bad is it if this happens?